Hello and welcome to Algorithm Integrity Matters. Insights for financial services leaders who want to enhance fairness and accuracy in their use of data, algorithms, and AI. I'm your host, Yusuf Mullah. This article was published in October 2024. It's titled Deprovisioning User Access to Maintain Algorithm Integrity. Security, of course, is an important aspect of algorithm integrity, and so some things that we've been seeing recently around user access and security-related matters is deprovisioning, which is about making sure that terminated employees don't have access anymore and people that just don't need access anymore or haven't been using their accounts don't continue to maintain that access. So this article will explain briefly why this is important and then what needs to be done. So here we go. The integrity of algorithmic systems goes beyond core algorithm accuracy and fairness. In a previous article, we outlined key aspects of algorithm integrity. Number 5 in that list, of course not in any order of importance, is security. The algorithmic system needs to be protected from unauthorized access, manipulation, and exploitation. In this article, we'll explore one of the key subcomponents of this, deprovisioning user access. Let's start by understanding deprovisioning. Revoking user access helps maintain security and, by extension, algorithm integrity. When users retain access that they no longer need or should no longer have, it can lead to unwanted activity, including unauthorized transactions, access to confidential data, IP theft, so for example, access to confidential models, and exploitation by malicious actors, things like denial of service attacks. We'll focus on 2 triggers for deprovisioning, being termination, for example, of employment, and dormant accounts. Other triggers exist, like changes in job roles, but termination and dormancy are typical and fairly risky. And here are 2 examples that demonstrate this. So the first is external attacks. The US National Coordinator for Critical Infrastructure Security and Resilience released an advisory recently, and there's a link to that in the article, and we'll put it in the show notes as well. That advisory explains that malicious actors have targeted dormant or terminated accounts. Internal attacks are a little bit different. So this is number 2, second example. With internal attacks, what we often see is that the access is by an existing employee using a password left behind, or something similar. The result is unauthorized changes to algorithmic parameters or data inputs. It could also be privacy breaches. Internal attacks are not often exposed for several reasons. They're also sometimes harder to detect because they come from within the trusted environment. And they are internal attacks, as harsh as that may sound. The activity could be considered fraudulent. Back to the 2 triggers and what we can do to reduce the risk. The first one was termination. When users leave, retaining their access can lead to serious security risks that directly reduce integrity. Here's 3 of those. Unauthorized activity. If accounts assigned to former employees are retained, their accounts might be used to initiate unauthorized activity. A former employee is usually not accountable for such actions after they leave, so anything done with their account. It's the organization's responsibility to remove their access. Another risk is bypassing segregation of duties controls. So where you have maker-checker controls, if a current employee has access to a former employee's account, they could log in as themselves to initiate the transaction and then use the other account to approve it. Or, for algorithm change control in particular, they could use one account to make a code change and then use the other account to migrate that change to production. Those controls exist to prevent fraud and also errors. So an errant line of code could go unnoticed, resulting in reduced algorithmic integrity. Third risk here, or third example of risk, is data breaches or IP theft. Accounts belonging to former employees might be used to view or extract sensitive data or models, resulting in confidentiality breaches. This can include customer information or even proprietary models. The solution to this is reasonably simple. So here's a couple of things to do. Revoke access when an employee or contractor, including vendor personnel, leaves. Disable user access on or before the date of termination. Set up automated deprovisioning processes to revoke access on time. conduct regular reviews to verify that terminated users no longer have access to systems. Now, in practice, this can take some effort, but the benefits generally outweigh the costs. The second trigger was dormant accounts. Accounts that aren't accessed regularly are risky. They are prime for exploitation as they're often not actively monitored. This could lead to similar risks to those outlined for termination earlier. So for dormant accounts, the solution: first, determine what a reasonable period of inactivity is. For example, if people typically log in once a month, perhaps a threshold of 90 days. Check account usage regularly to identify dormant accounts, so that's accounts that exceed our threshold that we identified in step 1 of inactivity. Deactivate accounts that are no longer needed, and consider strengthening other known dormant accounts. So for example, if certain service accounts are used less frequently, these are usually background accounts for integrations and things. If those sorts of accounts are used less frequently but need to be active, then implement mitigating controls like more complex passwords and then actively monitor their usage. And finally, consider automated tools to identify and deactivate dormant accounts. So those were the 2 triggers and some broad risks and broad solutions to deal with them. Some additional considerations. If automated deprovisioning is not possible or not feasible, and you use a manual process, exercise extra caution and emphasize regular reviews. For automated deprovisioning, if you can do it, perform regular checks to make sure the automation functions correctly. These things can and do break. When using single sign-on SSO systems, so this is where you log in once and don't have to enter passwords again for other applications, check for termination and dormancy at the application level too. For example, if you use Active Directory or Google Identity Services for authentication, single sign-on authentication, it is tempting to disable access there, Active Directory for example, and then assume that all is well, because that controls authentication everywhere. This can be risky. Applications sometimes allow direct or non-SSO logins, so this is even those applications that are primarily SSO. Sometimes they can allow direct logins for generic accounts and for other reasons. Employees return, sometimes to different roles, and then they don't need the access they had before. Reactivating their SSO credentials automatically gives them their previous access. So like reactivating their Microsoft Active Directory account will then automatically give them the application access if it hasn't been revoked. It is safer to disable or revoke access everywhere. Consider additional measures when systems or processes or behaviors change. So this includes changes like these 2 examples. The first is if you implement multi-factor authentication or MFA and users are forced to enable MFA when they next log in, dormant accounts will remain unprotected. Dormant accounts mean they're not logging in, and so they just won't have MFA applied. So have a plan for dealing with these. Second example here about additional measures for change. If you automate processes and login activity is more frequent, perhaps the dormancy threshold should be reduced. For example, if something like timesheets were manual and are now processed through the HR payroll system, employees may need to log in fortnightly to complete those timesheets. If you were using 90 days as the threshold before, maybe reduce it to 30 days because people are more active. Wrapping up, proper deprovisioning of user access contributes to algorithm integrity. We need to make sure that only current and authorized users have access. Getting this right is not difficult. It does take some effort, and the effort needs to be sustained. But without it, we risk losing integrity. That's the end of the article. Thanks for listening.